find the minimum value of x square plus y square plus z square when x plus y plus z which is equal to 3a. Here we have to find the minimum value for the function. Here this function is u, x square plus y square plus z square, subjected to the condition x plus y plus z is equal to 3a. This function is v. First take the function as u is equal to x square plus y square plus z square. Call this as equation number 1. Here this condition we can call this as v is equal to x plus y plus z. If we take 3a to the left hand side, that becomes x plus y plus z minus 3a. Call this as equation number 2. In previous classes, simply we studied how to find the maximum value or minimum value, but this problem is about to find the maximum value or minimum value of a function subjected to some particular conditions. Both are different. Understand carefully. Here what's the first step? We have to form the auxiliary equation. What's the auxiliary equation? F is equal to u of x comma y comma z plus lambda into v of x comma y comma z. We have to substitute u and v value for the auxiliary function. That is f is equal to u is x square plus y square plus z square plus lambda into v is x plus y plus z minus 3. After forming auxiliary function, we have to find fx is equal to 0, fy is equal to 0, fz is equal to 0. Here fx is nothing but partial derivative of f with respect to x. Here fy is partial derivative of f with respect to y. Fz is partial derivative of f with respect to z. First find fx and equate to 0. Here fx is nothing but differentiation of x square is 2x plus here y square plus z square is constant. So differentiation of constant is 0 plus lambda into differentiation of x is 1 plus here this becomes 0. Hence we get the value of fx as 2x plus lambda. We can equate to 0. Similarly find fy and equate to 0. We get the value as here f is this partial derivative of f with respect to y means this is differentiation of y square is 2y plus lambda into differentiation of y is 1. Hence we get 2y plus lambda which is equal to 0. Similarly fz is 2z plus lambda which is equal to 0. Here 2x plus lambda is equal to 0, 2y plus lambda is equal to 0, 2z plus lambda is equal to 0. Next step we have to find x, y, z and lambda value. Here 2x plus lambda is equal to 0. This implies lambda is equal to minus 2x. Similarly this lists lambda is equal to minus 2y. Here lambda is minus 2z. Here we get the value of lambda as minus 2x, minus 2y, minus 2z. Hence we can conclude that lambda is minus 2x. Here also lambda is minus 2y. Here also lambda is minus 2z. Hence we can take it as minus 2x which is equal to minus 2y which is equal to minus 2z. Or we can simply write it as x is equal to y is equal to z. Here minus 2x is equal to minus 2y which is equal to minus 2z. Hence we can cancel minus 2 in these three terms. Hence we can simply write it as x is equal to y is equal to z. After obtaining x, y, z values, next substitute x is equal to y is equal to z in the condition v is equal to x plus y plus z minus 3a. We get the value as, here substitute in the place of y and z as x, we get as x plus x which is equal to 3a, which implies here x plus x is 3x which is equal to 3a. Hence we can get as x value which is equal to a. Similarly in the place of x and z substitute as y, we get the value of y as a. Similarly substitute in the place of x and y value as z, we get the value of z value as a. Hence we get the value of x as a, y as a and z as a. After finding x, y, z values, to find the minimum value for the function x square plus y square plus z square means you have to substitute x, y, z values for this function u. Hence the minimum value of x square plus y square plus z square which is equal to, here in the place of x substitute as a, that is a square plus in the place of y as a and z as a. Hence we get a square plus a square plus a square which is equal to 3a square. This is a minimum value for the function u, that is x square plus y square plus z square, subjected to the condition x plus y plus z which is equal to 3a. This is a procedure to find the minimum value or maximum value subjected to some condition. Here to find the minimum value or maximum value means first step we have to form the auxiliary equation. After finding auxiliary equation, we have to form the equation as fx equal to 0, fy is equal to 0, fz is equal to 0. Using that equation, find lambda value. After finding lambda value, we get the value of xyz. We have to find the values of xyz means we have to substitute for the given condition. We get the value of xyz. After finding xyz value, we have to find the minimum value or maximum value. Substitute that values in the function u. We get the value of minimum value or maximum value for the function. This completes the problem.